Hi guys, this is Ed with the null operators. This is the second video in our video series for how to learn to code in Java. In this video, we'll be covering data types, variables, and console I/O. So, when talking about data types, what do we mean? Well, first we need to talk about computer memory, which you can kind of imagine as this grid over here. So it's just a series of blocks, right? And each type of data that we want to store in memory takes up a different number of blocks. So say I wanted to create an integer, right? Maybe that takes up 4 blocks. And if I wanted to create, say, a Boolean, maybe that takes up 2 blocks. So this is kind of the reason we have data types, is that the computer needs to know beforehand how big a variable is when we declare it. So we need to specify the data type so it can allocate the right amount of memory to that variable. So let's talk about what the actual data types are then. We have byte. We don't ever really care about byte, so we're just going to ignore it. And then we have short and int and long, which are 3 types of integer data types. Integers meaning whole numbers, right? So we have 3 different kinds of them, again, because of that size limit that we were talking about. So integers range from about -2 billion to +2 billion, right? So these, if we have a number that's greater than 2 billion, right, how do I store it? I still want to be able to store numbers that large. Well, in that case, we would need to use a long, because a long is basically just, it's an integer that has more space, so we can store a larger number in there. And then the short is the opposite. It takes up less space, so if we had a smaller number, we could be efficient and not waste space by storing it in a short instead of an integer. So those are our 3 integer data types. Most of the time, we're just going to be worried about integers. The important thing is that if you have an error message that tells you like integer overflow, then that means that you should be using a long instead of an integer because the number is too large. So we'll get rid of this, and we'll erase this. All right, so float and double. What are these? Well, we talked about how integers were whole numbers. Well, float and double are called floating point numbers. They're for decimals, right? So if I had like 1.23, that would be a float. If I had, 5.921, that would be a double. And kind of similarly to the integers, these both deal with floating point, right? It's just that one of them is twice as long as the other one. I think doubles go to about 14 decimal places and floats go to about 7. So if you have a super long decimal number, use a double, but if it's not that bad, then you can just use a float. And you'll notice that when I wrote that 1.23, I put an F on the end. So in code, whenever I'm using a float, I need to make sure to include the F at the end of a float, but the double, I don't need anything after it. Okay, so talking about characters then. What is a character? Where a character is basically just a symbol. So something like an exclamation point or the letter A, or even a number, right? The number 0 is a character. So these are all the symbols that we use to make up words. A character is a single one of those. Even a space is a symbol. And you'll notice that for each one of these symbols, I put single quotes around it. That's how we denote characters in code, is with those single quotes around it. And you'll see that whenever we open up the code and actually start creating variables. But for now, this should be enough. So that's characters. And the last one that we have is going to be our Boolean variables. So Boolean is pretty simple. It's just true or false. So if I have a value that I need to store as a true or false, then that's what I would use, a Boolean. All right, so let's move on to variables. So for our variables, we're going to go ahead and open up JGrasp. So I have JGrasp here on my taskbar. I'll open it up. And of course, you can use whatever compiler you like. I just prefer JGrasp, so that's what I'm going to be using. And we'll go File, New, Java. And I'll write my little shell here, public class, and I'll call it test. And then we'll do our public static void main with a string array of arguments. So this is something you're not going to understand yet. We'll break it down whenever we get to classes and methods. For now, just memorize this. Every time you write a new program, you're going to have public class, whatever you want to call the program, and you're going to have public static void main with a string array of arguments every single time. So this is where we're going to write our code down here. And let's talk about variables, right? We went over the data types, but how do I actually create a variable? How do I actually take up one of those blocks in memory? Well, we start off with the data type. So say I wanted to create an integer, or let's make a character. So I'll say character, and then I'll give it a name. And this name can be anything as long as it's not a number. So I can have something like ed2, but I can't just have 2. So we'll call this ed. How about that? So character ed, and then we can put a semicolon, and that'll declare the variable. That'll take up the space in memory. It'll allocate the space. But we can also go and give it a value right here. So I'll show you 2 different ways to do this. We can go ed equals a space, which is a character, or I can say char Adam equals an exclamation point. So on the first method, I declared the variable on the first line. So we'll write a comment saying declare variable. And then on the second line, we gave it a value, which is called initializing the variable. Now, what we did for our second character, we created a second character called Adam. We both declared and initialized it all in the same line. So you can do those things. Hold on, this misspelling is getting on my nerves. So you can do them on separate lines, or you can do them on the same line, is what I'm trying to get at. So that's how we would declare a character, right? So data type and then name equals value. So we'll do it with an integer as well. So let's say int Charlie is equal to 10. If I went and I then printed these values out using that print line that we used in the last video, I can say I'll print out ed, and then I'll also print out Adam, and I'll also print out Charlie. So moving down here, we'll paste this and paste this. And I will instead do Adam and Charlie. And you'll notice we're using the variable name. So I'm printing out, I'm sending to the screen the value of the variable. And I do that by referencing the name. So I know that whatever is stored inside of ed is stored inside of ed. So I'll say print out whatever's in ed. Print out whatever's in Adam. Print out whatever's in Charlie. So I'll save this before I run it because JGress wants me to do that. And I'll put it on my desktop. And this is kind of important where you save this because you'll need to go to this location to retrieve it later. So put it somewhere you can find it, basically. So we run this, and we see on the first line, we have an empty space because that's the value of ed. It's just an empty space. And then we have an exclamation point. That's the value of Adam. And then we have a 10, and that's the value of Charlie, right? Well, what if I said something like Charlie is equal to itself plus 5? Now, this might look a little confusing, right? Charlie equals Charlie. Well, how does that make sense? Well, what we're saying is the new value for Charlie is equal to the old value of Charlie plus 5. So now our last print line will give us a 15 instead of a 10. So let's transition into some of that arithmetic since we're already doing it here. I'll get rid of all this, and let's create an integer, and I'll just call it variable. And I'm going to say that this thing is equal to 10. And like we said before, we can say the variable is equal to itself, if I could spell, plus 5. And I can also do something like variable is equal to, let's do this. Let's do 15 divided by 2. Or even better, let's do 27 divided by 2. So what's going to happen here, right? First, we assign it a value of 10. Then we say that its new value is its old value plus 5. So it's going to be 15 at this point. So we'll put some comments here. It's 10 here. It's 15 here. But then here, what we've done is we've overwritten the value. So everything before this doesn't even matter anymore because I'm saying that the value is going to be 27 divided by 2 here, which should be 13.5, right? Well, if you were paying attention with the data types, you'll notice that we're dealing with an integer, right? Integers are whole numbers. So what's going to happen if I try to display this? Because that's 13.5 is not a whole number, right? So we run this, and whoop, print line, not a problem. So we run this, and we get a 13. So whenever we have an integer that gets a decimal value attached to it, it ignores it completely. So that 13.5 just became 13. So that raises the point, well, how would we deal with decimal values? That's where those floating point data types come in, right? So I could say float, and I'll call this variable 2 is equal to 27 divided by 2. But we're still going to run into an issue here, and I'll show you why. So if we print out our variable 2, now that we've assigned the value, right, we're going to end up with 13.0. That's still not 13.5. And the reason for that is that there are two different kinds of division in coding. There's integer division, and then there's decimal division. So what we're doing here is integer division. And the reason you can tell is that the bottom number is a whole number. Basically, the denominator determines what your answer is going to be. So not only do I need to store this in a variable that can hold a decimal answer, I also need to make sure I'm doing decimal division. So I'll just put a 0.0f on there. So I'm saying that the bottom number is a decimal, so my answer needs to be a decimal. And when I run this now, I'll get my 13.5. So the last thing that I want you to see in action is just that Boolean data type. I'll create a variable of type Boolean so you can see how it's actually written, right? So we have the data type first, Boolean, and then the name of the variable. I'll call this one var1. And we could either just put a semicolon, or we could immediately give it a value. I'm going to immediately give it a value, and I can say true. So you'll notice it turned into purple text. That's because this is a keyword. So I can give this a true or a false, and that's our Boolean variable. And if we printed this out, we'll see that we get whatever we stored in there, which is false. So one other variable that you're going to make a lot of the time is a string variable. So a string is a data type, but it's not a primitive data type. Remember, the 8 that we listed before, those are the primitive data types. A string is actually an object, but we're not going to cover what an object is just yet. That'll be down the line. All you need to know is how to declare a string and use it, right? So in Java, I'll use a capital S. I'll say capital string, give it a name. I'll call it Ed. And like characters, they have the single quotes, right? Well, strings, they have the double quotes. So I'll open up some double quotes, and I'll say like hello, right? So that'll be my string. And all a string is basically a sequence of characters. So instead of having a character for each one of these letters, we could just put it all into one string for hello. And if I printed it out, I do it the exact same way as I would with any of my other variables. I just print out the name of the variable. So I say System.out.println ed. I'll get the word hello. All right, let's move on to console.io. So what does console.io mean? Well, it's either sending a message to the console or reading a message from the console, right? So this down here that we've been dealing with, this is the console. So all of these print statements, these are called print statements, that is sending a message to the console. Well, that brings up a point of how do we read a message from the console, right? So let's say instead of just giving this variable for the string a value, let's say I wanted to read it from the user. The first thing I need to do is import something called a scanner. So import java.util.scanner. And for now, this is something you're going to need to memorize. But this is import this to read user input. All right. So we'll need a scanner in order to read user input. So first step, import it. Second step, actually create a scanner. So I'll create this scanner and I'll call it scan. I'll say that's a new scanner with system.in. So this probably makes no sense to you whatsoever, and that's perfectly fine. This is another thing that you're just going to need to memorize for now. Once we get to objects and classes, we'll break down what you're seeing here. But for now, just know that anytime you want to read user input, you first need to import the scanner class, and then you need to create a scanner. So this is create a scanner. And then the last thing is to actually use it, right? So to use a scanner, we're going to have the name of the variable, in this case, Ed, because I want to put a value into ed from the screen. I'll say ed equals scan.next. So bear in mind that we're using this .next because we're using a string variable. If I had a different data type for my variable, say I had int a or float b, boolean c, and I wanted to read those in, I would need to change that next to match the data type. So instead of just being next, it would be next int. Or if I was reading in b, it would be next float. So it's just the data type in all caps. The only one that you don't need the type is for strings. It's just .next. So you can see all of those. No, not next f boolean, but next boolean. So since we're using a string, we're just going to have next, and we're good to go. So the variable that I want to read, ed, is going to equal the name of my scanner, scan.next. Okay, so this is the line of code that is actually going to get the value from the screen. So value from the screen and store it in the variable ed. So now if we run this, before we were getting a value, now we're just getting this blinking cursor, right? So what's happening is the computer's waiting for you to enter a value and press enter so it can continue running. So I'll just say blah, 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 and I'll press enter, and we see that it gets stored in ed so that whenever we print out ed, we get that exact same value. So let's do something a little different. I can actually create two variables on the same line if they're the same data type by just introducing a comma. So if I'll say I've created a string ed, I want to create another string called Adam, and I'll read in a value for ed, and then I'll read in a value for Adam, and then I'll combine those two strings. So just like before, the variable that I want to put a value into is going to equal the name of the scanner .next. So now, if I do this, this plus sign, usually we see a plus sign, that's going to be math, right? Well, when you're dealing with strings, when there's a plus sign, what happens is you basically smush the two strings together into one. So I want to take whatever the value of ed is and basically attach Adam to the end of it. So if we run this, I'll say the value of ed is going to be hello, and the value of Adam is going to be world, and we see we get hello world at the end. And this is all well and good and all, but I kind of just have these blinking cursors on the screen, and I don't really know what the program wants from me, right? So anytime you're writing, you're getting user input, you want to give a descriptive message to the user telling them what you actually want from them. So before I read this value, I'm going to write a message saying, please enter a word. And then I'll do the same thing before I read the second value. Whoop. I want to copy that, not remove it. And here I'll say, please enter a second word or another word. So if we write this, run this rather, we'll see, please enter a word. Cool, now I know what it wants from me. I'll say, hi. And my other word will be bye. So now I get hi, bye. And similarly, we can do something similar with our output down here. I can say, you entered and boom. So this has gotten a little funky, right? We have the green text here, which is called a literal string. Anytime you have just text inside of quotation marks, that's called a literal string. So we have our literal string, and then we attach the value of ed to the end of it. We attach another literal string, and then we attach the value of Adam. So anytime you're dealing with strings and you see these plus signs, remember, we're just smushing everything together. Now, one thing to notice is that I made sure to put spaces at the end of each word and before each new word, because if I didn't, everything would be all mashed up, right? So if I take away those spaces and we run it, and this time I'll just say A for the first word and B for the second word. So it says you entered A and B, but it's all crushed together, right? I don't want that. I want spaces. So I'll add in those spaces. and that looks a lot better. So the last thing we need to talk about is we've been using println this entire time. There's actually two different types of print statements. There's a print, which I just get rid of the ln here. So this ln that my cursor is on, I can delete that, and that would just be a regular print. Well, what's the difference between the two? What a print line does is at the very end of the message, so we have this literal string, right? It says, please enter a word. Once it's finished printing that to the screen, it then drops down the cursor to the next line. Whereas a print only puts the message on the screen and leaves the cursor at the end, kind of where my cursor is here. So that's useful if you want to have multiple print statements, but put everything on the same line, you would use a print. Whereas if you wanted to create a new line after each print, you would use a print line. So let's look at that in action, right? Let's say I turn this into a print. What's going to happen? Well, if we look at our output, we had please enter a word, and then it dropped down. We got the user input, and then it dropped down. So what's going to happen now is, since it doesn't drop down, we'll have please enter a word, and then whenever the user enters the value, it'll be right here beside it, which can look a little bit nicer. So let's run it. It says please enter a word, and I say Adam. So the first one with the print said please enter a word, and then I attached it right at the end there. And the one with the print line, the second word, it dropped down. So you can see the difference there. Yeah. All right, so that'll be everything for console.io. So one final thing I want to show you is how to actually locate your Java program in your files. Some of you may be students, for example, and need to submit this for an assignment. So if you ever need to do that, I'll show you how to locate that Java program in your files. So in JGrasp, we see that we have our program is located in the C drive, users, Atom, desktop. So we'll just need to open up our File Explorer and track that down. So I will go to this PC, C drive, users, Atom, and then desktop, which is here. And I'll see I have test and test.class. The one that's important is the .java file, this bottom one. And you'll see that the type says JGraph's Java file. It'll just say Java file depending on whatever compiler you're using, but this is the one that you want to actually submit because that's the code that runs. The class is just basically metadata for that Java program. All right. All right, everyone. Thanks for watching. If you're looking for a little bit of extra practice, I have a little challenge for you here. So try and get this done at home. You should have all the tools you need to do it from these videos. And please make sure to like and subscribe. It helps us greatly. And I'll see you in the next video.